Well, welcome back to our podcast with Ben Turner. This is part 2 of the conversation with Ben, who is CEO of Origen. And I will ask him, just in case you missed part 1, I will ask him just to reintroduce himself. But the focus for today, the broader conversation is about zero carbon lime. Today, in the episode we're recording right now, is actually about UK specifically, and we're going to take a look at a particular project that's just broken ground and explore that in some detail. But Ben, for the sake of those that are coming into this episode before episode 1, who are you and what are you doing at the moment? And then we'll talk about the project.
Absolutely. Thanks, Alex. So as Alex said, my name is Ben Turner. I'm the CEO of Origen. We are a technology company developing technology to decarbonize the lime industry. And we're using that technology to springboard into at-scale carbon dioxide removal. So big ambitions, but starting with a really tangible industry opportunity in terms of the lime industry today.
Great. Okay. Good scene setter. So let's start then. The lime sector, when we talked in part 1, it's kind of fascinating. It's one I described it slightly clunkily as an invisible industry, but what I really meant by that was just it feeds into things in ways you really wouldn't expect when you're coming from the layman's perspective. But let's look at the UK particularly. Just give us some size and scope. What's the kind of volume of production? What's the size of the market here that you're targeting?
Yeah, so UK is quite a small market in terms of lime demand. If you think globally, it's 400 million tonnes. The UK market fluctuates between maybe 1 million to 1.2, 1.25 million tonnes of lime each year. Main end markets are the steel industry, but that's kind of the case globally as well. We've also got construction, building materials as a big consumer of lime. And then kind of growth areas would be maybe environmental uses, so wastewater treatment, flue gas desulfurization. Those are kind of your key main markets. To make it a bit more tangible, perhaps for consumers, lime is also used in the manufacturing of sugar. So all those Mars bars we eat or don't eat have a huge amount of lime that's used in those processes. And as I also mentioned, wastewater, but actually water purification. So those bottled waters that we're drinking typically have had lime involved in their production processes.
And one of the stats that I hadn't heard before, but which you used in part 1 was this kind of the sheer volume of CO2 produced from the processing of this material, of the ultimate end use material. I think you said that for the 400 million tonnes of lime produced, there's 400 million tonnes of CO2. I didn't misremember that, did I? Because I remember something like, oh my goodness, that's quite a stat to play with.
No, that's spot on, Alex. For every tonne of lime produced, about a tonne of CO2 is emitted. It depends on what your fuel source is. So if you're using coal, as rotary kilns might use, that's obviously more environmentally unfriendly than perhaps using biomass-derived pellets or natural gas or something like that. So on average, I think it's fair to say that a tonne of lime results in about a tonne of carbon dioxide emitted.
Okay, so there we are. We have a bit of how the land lies in the UK. We've got a bit of a feel for the level of CO2 that the sector as a whole produces. And we're going to dive on into your, I think it's the first project to break ground, isn't it? This project at Singleton Birch. Maybe you could just give a bit of a sense of, as your first kind of landmark site, how did this come about? And tell us a bit about the scope for this project and where it is in the UK as well.
Yeah, absolutely. So it's probably worth just introducing a little bit of history of Origen here to understand how Origen and Singleton Birch sparked up a relationship. And then I can kind of give an idea of Singleton Birch. So Origen's really primary focus, or our vision statement, is the atmosphere restored. So we believe that lime as a material is extremely valuable and extremely well placed for the purposes of at-scale carbon dioxide removal. And so if we go back to the very beginnings of Origen's story, Tim Kruger, who's the founder, recognized that lime had these great properties, looked at utilizing lime in the oceans to combat basically ocean acidification, but very quickly realized that there were social pressures and social hurdles that needed to be cleared before that became an accepted route. And really through that work, Tim reached out to Singleton Birch to better understand lime characteristics, the manufacturing, the production of lime. And so that really prompted the initial engagements. And then really about 3 years or so ago, when I got involved with the business, I really picked up the engagement with Singleton Birch. We raised some capital, and really on the back of the combination of those two factors, we agreed to partner with the purposes here of building a pilot plant which demonstrates the production of zero carbon lime. That is lime without any carbon dioxide emissions being vented into the atmosphere. So that's kind of where the idea and the project comes from. Singleton Birch themselves are a really interesting organization. So very old organization, been around since the 1800s, real focus on sustainability. And Singleton Birch are actually owned by three of the biggest charities in the UK. And as a result of that kind of ownership structure, they take a very long-term view in terms of investments and in terms of projects and in terms of sustainability. And so for us as an organization very much focused on sustainability and Singleton Birch sharing those values, for me, it made great sense here for the two businesses to be working together and partnering on a project like this.
Okay, and this is in the Humber region, so also kind of an interesting area in the UK for those who aren't, from who are listening, who are not from the UK. Obviously, this is kind of one of the centres of offshore CCUS, onshore carbon capture in the UK. So there's probably some interesting affinity there between the project you're doing and some future possibilities.
Yes, absolutely. And that actually is very key, Alex. So thanks for reminding me about that. So several months or so ago, CCUS phase 1 basically announced the two big industrial clusters in the UK that were going to have transport and storage infrastructure for carbon dioxide kind of developed and implemented. One was HyNet, which is the northwest kind of Liverpool way. The other is East Coast Cluster, which is Teesside and Humberside. And the exciting thing for this project and future projects with Singleton Birch is the CO2 pipeline is essentially going to go right past their front door. So that minimizes the amount of extra pipeline that we need. And access to that infrastructure is critical for being able to call our lime zero carbon lime.
Let's have a look at the technology. I know it's always fun on an audio podcast to ask people to describe their technology, but see if you can paint a picture. Obviously, you've mentioned already it's a kiln technology, but what does that mean? Tell us about that.
Yes, so the best way really of explaining what the technology is to compare it to existing technology. So it's also probably best just to explain how lime is typically manufactured. Now, for anybody from the lime industry who's listening to this, I really apologize if I've overly simplified it, but I think for the purposes of just the layman, so to speak, I am going to deliberately keep it simple. So lime production is essentially akin to putting a lump of lime into an oven at about 1,000 degrees centigrade. And to generate those temperatures of 1,000 degrees centigrade, I need to burn some form of fuel. That's typically natural gas, maybe coal, maybe biomass. And at that temperature, calcium carbonate, which is limestone, breaks down into lime, calcium oxide, and carbon dioxide. And that carbon dioxide is quite dilute, and at this point in time is emitted into the atmosphere. And that's where that kind of 1-for-1 ton of lime to 1 ton of CO2 comes from. The fundamental issue with that process is the combustion that occurs in air. There's a lot of nitrogen in air, which therefore means that there's a lot of nitrogen in the flue gas, which is why you have a dilute stream of CO2. With Origen's process, we're still generating temperatures of 1,000 degrees centigrade, but we are combusting in oxygen, which means that we exclude nitrogen from that process, and we end up with a very high purity stream of carbon dioxide coming out of the top of the kiln, which makes it very easy to capture and do any additional cleanup that needs to happen before it's sent into a pipeline. So the key to this is oxycombustion. We've got some smart ways of significantly reducing the cost of the oxygen that is required for that process, which makes this economically viable. But we are ultimately generating lime, a high purity stream of CO2 that can ultimately be sequestered or stored.
Listeners will be from backgrounds as diverse as industry to investment to other startups with different technologies. For those in investment with that as a background for those who are from other types of early stage tech? Often what we hear is, but what did the customer ask? Like, what hurdles did you have to overcome? What were the industrial clients' concerns or kind of question marks? Because it sounds, the way you just described it, it sounds like such a simple, obvious, no-brainer, switch this to this, but there must have been, I'm sure, questions that came up along the way. So tell us a bit about that.
Well, I think the overarching priority here for an industry like lime, it's equivalent to cement as well, because limestone is a key raw material for cement manufacturing, is really the carbon dioxide problem. So how are you going to solve this issue of carbon dioxide? And for us, obviously, there's the there's the oxy-fuel side of things. That's really the key question. Some of the other questions that we're asked is the type of lime that we're producing. Now, lime is not a homogeneous product. You don't just get the same commodity spread across the whole industry and every user uses it in different ways. There are different types of lime, whether or not it's particle size, whether or not it's reactivity, whether or not it's other characteristics. Now, the characteristics of our lime are, I'd suggest, quite unique. We're powdered lime. We expect it to be highly reactive. That is not the largest portion of the entirety of the market, but really understanding that and understanding the applications of that lime are really critical here. So those are some of the questions that we get. And then I'd also just take this back to the bigger picture from an Origen perspective. For us, carbon dioxide removal is really the end goal. And for us, when we were thinking about technology development, we were thinking, what are the characteristics of lime that we need to kind of get bang for buck in a per ton lime, per ton of CO2 removal? And so that's what kind of prompted us to go down the route that we've gone down here. I think the other point I would make, and it's maybe not questions per se that have come our way, but feedback that has come our way. For a lot of industries, and lime is a really great example, there isn't one single silver bullet that is going to solve all of the carbon capture problems. There are technologies that are perhaps more applicable across more end markets than necessarily other technologies. But for the lime industry, it's difficult to say there is one solution and it is Origin's solution. That it's not going to quite be that way.
Yeah, I think that's a really interesting point. And that was one of the things that probably took me a little while to get my head around when I first started sort of stepping into this space of industrial decarbonisation last year, that it's not just you will need a portfolio of technologies, but different sites will need different portfolios of technologies. And that kind of the impact of local geology or just the general geography across which a plant or company operates. I really hadn't expected that to be such a driver of certain types of decisions.
Yeah, and I think that's one of the reasons why you see so many different technologies out there. You can go through the whole list of amines, membranes, solid sorbents, integrated approaches. All of those solutions are viable solutions. They are just not necessarily single technologies that will dominate the entirety of a market. Certainly, in my opinion, I think there are space constraints for some industrial users. There are geographical constraints. There are the specific properties of the flue gases. All of those things need to be considered when it comes to selecting the appropriate technology.
Just coming back to the project that we were talking about, Singleton Birch, I mentioned that you'd broken ground. Was it the beginning of November? I think that's what you said. So yeah. Where are you at, and how, what's the sort of timeline for the project?
Yes, so you're right. We broke ground at the beginning of November. Breaking ground entails basically some soil stabilization, so steel piling. We've poured a concrete slab in the past couple of days, or maybe the past week or so now. All of the equipment is ordered, so that's starting to arrive at Singleton Birch's site. And really the key components of this in terms of work plan begin in January. So January, we start building steel work from the ground up. The bespoke pieces of kit, which are Origen designed, start getting installed. Timeline-wise, we're expecting the build to complete kind of April time, 2022. We'll then move into a commissioning phase for 3 months or so, kind of April, May, June. And then we're going to be moving into what we're terming commercial optimization, which is really taking a lot of this feedback we're getting from the lime industry and all the conversations we're having, and really helping us better understand our technology, its application to the lime industry specifically, and, as I said, optimizing technology.
And once it's kind of fully up and running, obviously you mentioned that location for Singleton Birch is great once that offshore CCUS project is up and running. What happens in the interim?
In the interim, the pilot plant's small in the grand scheme of lime industry production. It's about 3,000 tons of lime and 3,000 tons of CO2 if we ran it 24/7, 365. So we're not producing huge amounts of lime here. We're not producing huge amounts of CO2. What our plan is essentially to capture that CO2. We'll sell that into the local market. It's not going to be a huge amount of carbon dioxide. So that's kind of the interim solution. But just bear in mind, the infrastructure is likely to be operational kind of 2025, 26. I might be being a bit optimistic there, but optimism's good. So in time, we'll obviously be able to push that through the infrastructure for storage itself.
Okay. I know when we were talking in the first part of our conversation, we were more focused on the US, and we talked about kind of opportunities and perhaps more opportunities for particularly onshore storage in the US. In the UK, like right now, there's less focus on storage. Yes, we have, these projects that you mentioned that have been getting some funding, but I'm wondering, do you see the wider landscape changing here? Can you see a future where there's onshore storage?
So I think that's an interesting question, because there are opportunities to store CO2 onshore in the UK. There are disused oil wells in geographies like Lincolnshire and North Yorkshire or Yorkshire. I think the reality is, though, we have a lot of expertise in the North Sea, both from a UK perspective, a Norwegian perspective, a European perspective. And at the scales we are talking about, in terms of tens, if not hundreds of millions of tons of carbon dioxide being stored in that area, it probably makes sense to leverage and repurpose the various different pieces of infrastructure we have there, as opposed to necessarily doing it onshore on the UK or in the UK. I think one of the key differences perhaps is the societal acceptance of storing CO2 onshore versus offshore. In the US, there's much more kind of onshore individual experience of hydrocarbon recovery as well as CO2 storage. And I think the barriers to, or the hurdles that have to be cleared societally, are less in the US, which makes it well placed for onshore CO2 storage. In Europe and indeed the UK, I think that's a slightly different and slightly more difficult issue to tackle. And therefore, the offshore side of things, I think, really is the route to go here. So
that being the case, then, I mean, the projects that you may have in mind in the UK, and the one you have at the moment, as you said, is at pilot stage. So it's relatively small quantities of CO2, but there will be a point, hopefully by the late 2020s, where we're talking at scale CO2 recovery and transport. What's needed now to make sure that we're ready for that, in terms of transportation infrastructure? What do we need to be keeping our eyes open for? If I'm an investor looking at companies that operate in this space, or if I'm an industrial, what are the things we should be advocating for or keeping an eye on to ensure that we're able to operate in an at-scale CCUS market?
Well, I think we're on track. Certainly the early steps are heading in the right direction. We've identified more than two clusters, because there's important clusters up in Scotland as well. But as far as government support to get the early planning, permitting, stakeholder engagement, assessments from a technical feasibility perspective, we're moving in the right direction. The reality is, Alex, these are massive infrastructure projects. They do just take a lot of time. If I just make a comparison here, out in the US, it's expected to take at least 3 to 5 years from our side of things to get the appropriate planning, permitting, pore space acquisition, et cetera, really fully implemented. So I don't necessarily think that these things can happen any faster. It just needs the support. And it's a little bit chicken and egg, because you are never going to build the infrastructure unless you know that there is going to be throughput of CO2 on that infrastructure. by the same token, as a industrial facility, I'm never going to invest a huge amount into carbon capture technologies unless I can do something productively, whether or not that is storage or utilization, with that captured CO2. So balancing those two factors out, I think we're heading in the right direction in the UK. Look, I'm a generally impatient person. I'd love this to be moving more quickly, but I actually think we've now got the momentum behind it. There is huge industrial support for these clusters that I'm talking about in the UK, and we just have to get on and deliver on it now.
So I do want to revisit something you mentioned both in part 1 and part 2, which was something I didn't really know a lot about until you and I connected, which is the use of lime and zero carbon lime as a CO2 capture tool in and itself. So what's the scope for that, and what, tell us more.
The great property of lime, calcium oxide, is it has a natural affinity for carbon dioxide. Lime, calcium oxide, is an unstable material, and it naturally wants to find itself in a stable carbonate form. And so that cycle, limestone to lime and back again, is called the lime cycle. And we're really trying to exploit that from a technology perspective. So by decarbonizing lime, we essentially end up with zero emissions of carbon dioxide into the atmosphere. And then for every ton of lime that reacts with carbon dioxide, it reacts with about 750 to 800 kilograms per ton of lime produced. And so what that means is you're essentially going negative in terms of CO2 in the atmosphere, or indeed CO2 in flue gases. And utilizing that property allows us then to, as I said, decarbonize other processes, or indeed remove CO2 from the air. So we're doing a huge amount of R&D. We've been very fortunate to receive some really significant funding from the UK government. We have got several academic partnerships with universities like Oxford University, Heriot-Watt, Cardiff University, Cranfield University, all really looking into ways in which we can leverage these properties of zero carbon lime at scale for the purposes of what I'm alluding to.
What sort of lime platform might exist, or what way might it be used to do that? Is that something you've got a feel for yet?
To keep this really simple, to be honest, if we take something like cement curing or concrete curing, that curing process is carbon dioxide reacting with the calcium oxide in the material and basically solidifying it. So that is what a CO2 removal process, essentially, we're already doing it. That is what happens. And actually there are many processes where lime is currently used in end markets and a carbonation reaction is happening and CO2 is getting removed. So if we use some building material examples again, something like a hempcrete block uses a lime binder, and as the lime reacts with carbon dioxide, it firms up the integrity of that structure, and that is essentially removing CO2. There's other routes you could go. You could think about spraying a lime wash on a material, or on a surface, and that lime wash will react with CO2, sucking out CO2 from the air. We can spray it again and spray it again. There's other routes that we're kind of looking at. So there are a huge number of avenues to explore. We've got a whole portfolio of ideas that we are trying to slim down to kind of focus on the here and now to get us to initial CO2 removal. And then a whole host of other ideas that catapult us to scale. And they all look different depending on kind of the route that we end up pursuing.
What next for Origen? What you talked about this project here in the UK, you talked in part 1 about the partnership with Volt in the US, but what's on the horizon in terms of fundraising or other activities?
Well, I think that the two key items, aside from fundraising for the moment, are very much get the pilot plant operational, which, as I said, should be operational middle of next year. The second aspect is really to drive towards collaboration with the lime industry. So we're out in the US focusing on some of the key players there, in large part because of the ability to store CO2 and some incentives. But that does not mean we're neglecting the UK and indeed Europe, far from it. There's several opportunities in the UK for us to build scaled up kits, again, with Singleton Birch, leveraging this transport and storage infrastructure. So what we're really trying to do now is take that pilot plant and scale it with partners. That's the key aspect. Running in parallel with that is obviously this technology development for the purposes of CO2 removal. And we've got some really talented engineers and then a new CTO who's really driving that side of things forward. I guess, unfortunately, for some people, fortunately for other people, this is really capital intensive. You can't get away from the fact that building big pieces of equipment do cost money. So from a fundraising perspective, as we start scaling this technology up, we ourselves are going to need to raise incrementally larger amounts of capital. So we'll be doing a smaller fundraise kind of early next year, but the key one is really Q3, Q4 2022, which would be to really drive us forward in terms of scale up of technology, as well as some of that additional R&D I was talking about.
Great. Okay, well, Ben, thank you very much for talking to us. Great to have two parts of that conversation, both about the US and the UK markets. And we'll look forward to seeing the completion of that first pilot project and perhaps reconnect then.
Absolutely. Follow us at origincarbonsolutions.com. We've got more blog posts coming out there. We're sending out more information as we kind of develop the business. So yes, keep an eye on us.
All right. And for listeners, you can check our show notes. I'll make sure that we include some great links for you just to explore a little more as well. Thanks again, Ben.
Super. Thank you very much, Alex. Thanks, everybody.
Many thanks for listening to the Decarb Connect podcast. We work with clients across the industrial sectors, specifically those who are tasked with decarbonising the most energy-intensive products and materials that we use every day. If you have an interest in learning more about either our members network, our reports, or our event series, do get in touch with us at decarbconnect.com. Or if you'd like to take part in the podcast, email me, Alex, at ac@decarbconnect.com. Thanks for listening.